Thanks a lot, Jim. The first thing I'd like to do is give a little bit of an overview of what we're planning to do today. We're going to spend about 10 minutes talking about the topology of the domain name system, and then spend the majority of the session talking about the security of the domain name system. That will be broken up in the sort of traditional way of discussing security between integrity, availability, and confidentiality. Then Amrish will spend about 15 minutes talking about the state of DNS security in Africa based on measurements that AFRINIC has performed and that others have performed. Then we'll have about 10 minutes of recommendations and insights from the panelists, and then we'll have 30 minutes of open Q&A. Now, you're very welcome, as Jim said, to pose questions throughout this. We have Nishal and Amrish and James who will work on getting answers to you to the questions. If there are topics that a lot of you are wondering about and we see a bunch of questions about, then Jim will bring that question to the fore and we will address it live. We will also have, to keep things more interactive, we'll have a bunch of polls. So we'll break this up between each of the little sections. We'll have a couple of questions for you guys to answer about your situation and what's important to you. Also be thinking about, in the bigger picture, whether there are questions that you'd like to see us addressing that we could do in a future webinar another week, because all of these are driven by requests from you guys. We're doing this DNS security because of questions that you guys have posed to us that we thought we could bring more content to you on this topic. Okay, so I'm going to get started with a bit of an overview of the topology of the DNS at kind of an introductory level, but I'm going to show you a diagram that's a little bit different than the one that you might be used to seeing. A lot of the diagrams of the DNS will start with a user talking to a recursive resolver, which then goes out to the authoritative name servers, the root, the TLD, and second level name servers. What I'm diagramming here is showing you a couple more stages. A user is in possession of a device, a smartphone, a laptop, and there are applications on that device. And those applications are the things that are actually performing the DNS lookups. When you load a web page and the web page contains an advertisement and the advertisement needs to go load a bunch of content, that's not the user initiating that. That's not the user typing in a URL. That's, you know, a DNS lookup that's being initiated by the application. So the application sends that to the system resolver. This is an inter-process communication call on the laptop or phone or whatever. And then a part of the operating system is going to go do that lookup. And it's configured to use a resolver somewhere else off the machine. Now that might be a recursive resolver. It might also be a caching resolver. A caching resolver is one that just sits, say, at the edge of your network and forwards queries to recursive resolvers on behalf of things on your network, but also caches results so that if the person sitting next to you does a lookup for the same thing 5 minutes later, another query doesn't wind up leaving your network. Then the recursive resolver, which in turn does queries to the authoritative servers on your behalf. Now, the 4 boxes on the right-hand side are each showing stacked, because those are places where there's potential redundancy that can be configured into the system to make it more reliable. Whereas the application and the system resolver, there's only one of each of those, so there's no redundancy within that portion of the diagram. Now, one thing you'll notice about this is that we progress left to right from things that are more easily secured and controlled to things that are less easily secured and controlled on the right. So the application is on your host. You own it, you control it in theory. The system resolver is something, again, that's on your device. You configure it, in theory, it will behave the way you tell it to. The caching resolver is something you have the option of setting up within your organization. If you're responsible for IT for your organization, you would build that, it would do your bidding, it would be under your control. A recursive resolver is something you could set up yourself. A lot of organizations do. Individuals mostly don't do that. If they have a fancy firewall at home, the firewall may have that capability, so they might turn that on. But mostly people are not using their own recursive resolver unless they're at work and they have an IT department that's done that for them. And then the root, TLD, and second level name servers are authoritative servers that are generally under someone else's control, unless we're talking about the domain name that you're responsible for, in which case a portion of that is going to be under your control. And again, we'll talk about that a little bit more later on. Now, how is communication done between each of these parts? From the application to the system resolver, that's interprocess communication, and the operating system of your device is responsible for securing that, to make sure that one application can't see the communications of another application. Now, is that perfect? No, not always. There are plenty of security vulnerabilities. We have malware that gets loaded into people's machines that downloads their address book or records their keystrokes or whatever. These are all kind of failures of security on the host. Those are things that the operating system should be responsible for. As these kinds of problems get discovered, in general, the operating system vendors will correct them. So, interprocess communication is generally reasonably secure. Then from the system resolver to the caching resolver, this is across your local network. You have the option of configuring that to use encryption, DNS over TLS, or one of the other alternatives. Most people are not going to bother to configure that for securing traffic on their own local network, which is probably going to be secured by layer 2 separation within the Ethernet, or they're not so worried about because there aren't untrusted devices on it or whatever. But as we sort of move into a future that has fewer people sitting in offices, more people in home offices, this idea of a trusted local network is becoming less of a thing. There's more dependence on end-to-end security, securing endpoints, and treating the network as always untrustworthy. So it's likely that going into the future, more devices will be configured to always use encryption for anything that leaves the device and not depend on something else to do that for them. Then between a caching resolver and a recursive resolver, this is more likely to be leaving your network. And again, DNS over TLS is going to be the best bet for encrypting that connection. And then between the recursive resolver and the authoritative name servers, there's not really guaranteed at this point to be any encryption at all. So by and large, that's still moving clear text across the internet. Now, there are ways in which people are trying to make that better. So many of you are aware that Nishal and I work for PCH, and PCH is one of the supporters of something called Quad 9, which is public recursive resolver. The way PCH and Quad 9 work together to solve this particular problem is by putting the recursive resolver and the authoritative servers back to back with each other. So that, again, is interprocess communication within a VM stack. So that's one way of securing that. And we'll talk about others in a few minutes. So there are ways of making all of these things better. There are ways of improving on this at every stage. So as I mentioned, across your local network, layer 2 segmentation of the network, VLANs and the regular functioning of an Ethernet switch that prevents traffic between two parties from being switched onto a segment with a third party, those kinds of things will help a lot. In a caching resolver, the bigger the cache, the less frequently it has to then go ask somebody else. So the bigger the cache, the more memory allocated to the cache, the more effective the caching resolver is as a privacy mechanism, as a bulwark between what you're doing internally and what the rest of the world can see that you're doing. Then there's something called QName minimization. With QName minimization, when you send a query out, you're only sending the portion that absolutely needs to be sent. Now, that's actually something that works better between recursive and authoritative than on a caching resolver, but would also work between a caching and recursive. Then the step from the caching resolver to the recursive resolver, you have to place some trust in the recursive resolver that you're going to use if it's not one that is completely under your control. A way that we would like to see that working more in the future is to authenticate the endpoint, authenticate the recursive resolver using DANE. So when your caching resolver or your system resolver goes to talk to the recursive resolver, it should try and make sure that the recursive resolver it's talking to is in fact the authentic one and not part of a man-in-the-middle attack, as for instance might happen if there was an IP address or routing hijack against that recursive resolver. And then, as I mentioned, co-locating recursive with root name servers or second level name servers is a great way to decrease the amount of traffic that is crossing the general internet with your queries in. So let's move on to one of the polls that I discussed. We're going to have two questions. First, does your organization operate its own caching or recursive servers? And second, do you know where the recursive and root name servers that you use are? So let's switch over to the poll. You saw the URL at the top and the code that you need to enter. Bashir, do you want to talk a little bit about how the poll works?
Yes, so kindly head over to menti.com and use the code on your screen, 278589. Menti.com and use the code 278589.
And then what we will see as people start to make their selections is this bar graph updating in real time. And so far, we've got very good news, which is that a lot of organizations are operating both their own caching and recursive resolvers. So a caching resolver might be in a branch office or something, or it might be actually on a host. And the recursive resolver is more likely to be at the edge of your network, sort of out in the boundary zone between the public internet, where it needs to send queries to the authoritative name servers, and you're inside where your hosts are generating queries. So this is actually excellent news. Let's see, I thought there was oh, I probably should have put a neither in there. But if the answer is that you're not operating either, why don't you just answer that as don't know, and we'll run with that. So I think what we're seeing here is really good news. The least popular option there is to operate a caching resolver only. So let me talk for a moment about that, because that's actually a pretty tempting alternative. A caching resolver is really simple to operate. There is software that you can basically just turn on and not tweak anything at all, point it at a recursive and call it done, and it will just sit there caching answers as they pass through from the recursive. To the end nodes, it looks like a recursive resolver, and to a recursive resolver, it looks like an end node, but it is maintaining the privacy of your organization by not passing through multiple answers, which means that, or multiple queries for the same thing, which means that somebody observing traffic from the outside isn't going to be able to distinguish the behavior of individuals within your organization. So if operating a recursive resolver is more work than you want to take on, it may be that operating a caching resolver only is a really good intermediate step that doesn't take as much work, but gets you, 80% of the benefit. Okay, let's go on to the next question. So in this question, what we're asking essentially is, do you know where the recursive and root name servers that you use are? Are they local to your city? Are they inside your country? Or sorry, I don't actually ask about the city. Is this traffic going internationally? The goal here would be to have as much of this as possible inside your country, so that the queries that you're sending out are not hitting international links that tend to be observed more and less under the control of you and your local authority. So having the recursive inside the country, but not a root, is okay. The roots tend to be really heavily observed. And so if there is a recursive that's local to you, and there are a lot of users of that recursive, there's a lot of chaff, right? There are a lot of other people using it. And so there's very little to connect a specific query with a specific user or individual. So that's good. It also means that the cache is going to be more effective if there are more users. So it doesn't matter so much if the root is outside, if the recursive is in. The recursive being outside the country would be a real problem, though, because then your whole query is going, across international links. At that point, you'd want to make really sure that you were encrypting the traffic going to the recursive. All right. So I think what you're seeing there is that the most popular is don't know, and out of 42 respondents. Okay, so a little bit of traceroute will tell you where you're going to. There's also something called a chaos query that you can do to see how the server identifies itself. And I think if anybody's curious about that, just throw it into the Q&A, and one of the folks answering will tell you how to do a chaos query and what kind of results you should expect to see. All right, let's go back to the slides now. So the way we talk about security has historically gotten fairly standardized, and we talk about it in terms of three things: integrity, availability, and confidentiality. Integrity is whether the answer we get is correct. Is it the right thing? Is it the authentic answer? There's also a time component to that. An answer that was correct yesterday might not still be correct. The correct answer may have changed over time. And if you're still getting an old answer, that's something that's often called a replay attack. A replay attack is replaying an old answer, which is cryptographically verifiable, but is no longer the authentic answer. Availability is what most people wind up talking about as DDoS. Are you able to get to a service, or is someone in a position to deny you access to it? Availability can also just be a question of reliability, right? If something fails a lot, you're being denied availability of it during those periods of failure, even if you're not under attack per se. So availability gets sort of mixed between security and reliability. And lastly, confidentiality is what you're doing private to you and whoever you're doing it with, or are there other parties who can tell what you're up to, who can see what queries you're making and when? So of these three, they're all important, but they're all fairly different. So we're going to discuss each one as a separate little section. First is integrity. Is the answer correct, authentic, and current? Integrity in the DNS is supplied using something called DNSSEC. DNSSEC puts a cryptographic signature over the DNS zone data. So when you do a query and you get a response back, if that response has been DNSSEC signed, if there's a DNSSEC signature over it, you can validate the data you've received by checking the signature. This is very similar process to what's used with a certificate on a website or with a digital signature on an email. This kind of cryptographic signature process is pretty well understood and established at this point. So in the DNS, this is a hierarchical system, and there are signatures at each level of the hierarchy on down to whatever specific answer you're looking for is. Now, if a portion of that hierarchy hasn't been signed, it's a break in that chain, and you're not going to be able to validate. So at this point, pretty much all top-level domains are signed. There are probably a few holdouts still, but I'd have to go look at current statistics to know for sure how many there are, but not very many. So then the question is the second level and the actual host name, is the signature done all the way down? That's a fair bit of work to make happen. On the other hand, if it's all signed, but you don't bother to validate it, you also don't get the benefit of it. So DNSSEC is really dependent upon two things, the signing first and the validation second. If both don't happen, you don't get the benefit of it, but you had to do the work. So often DNSSEC validation is not actually done in the device itself. Often that is pushed out to the recursive resolver to do that work. So a device will send a query to a recursive resolver. The recursive resolver will go get the answer, will do the validation, and then will pass the answer back to the host along with a flag that says this answer has been DNSSEC validated and it checks out. There is a problem with DNSSEC that there is insufficient signaling granularity from the validator to the consumer of the answer. So when something doesn't check out, typically you get a serve fail, which is the same response you would get if the authoritative server simply was offline. That's not enough information to really work with. The danger here is that the system resolver will say, okay, we got a serve fail when we tried using this resolver. We're going to switch resolvers and see if we get an answer from the other. And then you get an answer from the other. It's bogus data because the second resolver didn't do a DNSSEC validation and handed the answer through anyway. And so then the system resolver is going to think that that second resolver is more reliable instead of realizing that it's less reliable. So there's work going on in the IETF to solve that problem. The IETF, the Internet Engineering Task Force, where internet standards are defined. Okay, so DNSSEC works. If it's fully implemented, it does solve a lot of the DNS security issues. Cache poisoning is something you may have heard of. Cache poisoning is where a caching resolver or recursive resolver gets an answer stuck into its cache that is not the right answer. And so it never bothers to go out and get the correct answer because it thinks it's already got an answer. Man-in-the-middle attacks are the worst sort for the DNS because they're kind of the easiest to do. That's where you think you're talking to something, you're actually talking to something different. It gives you back a different answer perhaps than you would have gotten otherwise, or maybe it gives you back the correct answer, but it's just party to the transaction and knows what you're up to when it shouldn't. The DNSSEC is giving you a huge advantage if you use it, but you got to do the validation and other people have to do the signatures in order for that to work. Now, I already discussed the serve fail, and that's going to get solved. There's a process, draft IETF DNSOP extended error, which is now in its 16th revision and 4th year. And eventually people in the IETF will come to a conclusion on that, and we'll decide, you know, how it's going to work, and then it'll start to get written into software. Until then, we don't have that tool available to us. So the problem here, from a user perspective, is they're using an application, they're under attack, and all they know is that they can't connect. And that's the best case. The worst case is they're under attack and they do connect, and they think they're talking to their bank, and they're actually talking to something else. That's the worst case. Now, once the extended error messages are available, the resolver will be able to do the DNSSEC validation and pass a message back that the application can say, you're under attack, you can't connect right now because something is sitting between you and the thing you're trying to connect to and hijacking the traffic. But we don't have the information to do that right now. Then the other issue is that the key management, the cryptographic key management for DNSSEC is kind of complicated. Routine tasks are really well automated. So you just download the software and you run it, and you know, signing happens. But the more complicated things like key rollovers and key expiration and the changes of algorithmic, of encryption algorithm, those kinds of things tend to not be as well automated yet. And so that can turn a complicated thing into a really manual process that requires some research and so forth. So while it's simple and working well, it's easy. And then when things go wrong, it can get really fragile and really difficult really quickly. Better tools will solve that. Okay, so let's talk about the limitations of DNSSEC. Here I've drawn a slightly different diagram from left to right, a hidden master name server. So this is a server that contains DNS zone data in its unsigned form. This is the master server in which, in a database or a flat text file, we have all the DNS records, and when something needs to be updated, someone goes in and edits that in order to make that change. So a new person registers a new domain name, or a host moves, or whatever. Now, that information then gets transferred over to a DNSSEC signer, typically. Often, those are running on different machines, maybe because the DNSSEC signer is operated by a service provider, maybe because it's an appliance that they bought. So the connection between the hidden master name server and the signer is typically unencrypted. It's very subject to man-in-the-middle attack. And you're depending on the host security of the master name server also. So this is an area that we really encourage people to look at, finding other mechanisms to secure. Like, for instance, putting that hidden master name server behind a firewall that doesn't allow any other traffic, and having a dedicated encrypted tunnel like IPsec between the hidden master name server and the signer, for instance, would be a reasonable thing to do. Then between the signer and the authoritative name servers and recursive resolvers, everything's great. DNSSEC solves all the major problems. Then between the recursive resolver and the users, if the user isn't doing their own DNSSEC validation, then you've got to depend completely on the recursive resolver not being successfully attacked, being trustworthy, so forth. So in order for DNSSEC to work, you got to have the signing and you got to validate the signatures. So to keep things moving forward, to keep things getting better, we need the process of signing to become easier without becoming less secure. So we need it to get more of the functions get built into more of the tools, more automation, better documentation that is aimed more at neophyte users. And then on the other end, we need clients to validate for themselves and not depend upon a recursive resolver doing it for them. That way, you're not putting your trust in an external entity. Okay, let's move on to another poll. our first question here is, what are your DNSSEC signing plans? And our second question is, what are your DNSSEC validation plans? So our options here are, you're not yet DNSSEC signing any zone data. You're not responsible for any DNSSEC zone data. You're signing using an outsourced process, or you're signing using your own process. This is interesting. A lot of folks not yet signing, which is unfortunate, but at least you know where you need to be going. Interestingly, nobody yet signing using an outsourced process. So there are plenty of registry services providers and registrars that will do DNSSEC for you in a hosted service. And that's a fairly common service. Like if you register, I don't know, for instance, if GoDaddy does it, but I assume they do. You could have a domain name, have them providing the hosting and taking care of the DNS, but also having them do all the key management. So I'm kind of surprised that that's not more common among you folks. I guess it also all depends sort of what it is that you're responsible for, whether it's sort of host level or organizational domain level or TLD. ICANN requires that newly registered top-level domains, of which there are about 2,000 now, requires that they all be DNSSEC signed. And ICANN processes are such that it's fairly difficult to do that yourself, not to do the DNSSEC, but to act as the registrar. They're kind of captured by the registrar and registry services industries, which set up the requirements such that you pretty much have to hire one of them to act as a service provider for you. And so, of course, they all have that function built in. All right, let's move on to the validation question. So here, not DNSSEC validating, using an external recursive resolver to validate, or already validating within your organization. So within your organization would be either on hosts or on a recursive resolver or a caching resolver. External would be using something like Quad 9 or Google's 8.8.8.8 or Cloudflare. Quad 9 was the first recursive resolver to implement DNSSEC validation. Prior to that, everybody kind of assumed, oh, well, if we validated and stuff failed and we didn't give an answer, people wouldn't like us. But it turns out actually that people would rather be protected from hijacking, and there weren't a lot of complaints. And so after Quad 9 had been doing it for a couple of years, the others got on board and started doing it as well. So that's one of the points of Quad 9 as a nonprofit, is to sort of drive the industry forward and get other people to do best practices like DNSSEC validation. So for those not DNSSEC validating, the easiest way to do it would be to use an external validating resolver, one of the public resolvers that do it. You'll want to check and verify that it's actually doing it, but that's the easiest way. And then the harder way is to run your own recursive resolver with DNSSEC validation turned on. The hardest way is to do it at the host level right now, and that's really unfortunate. If you're running your own servers, they're Unix, you can certainly do that at the operating system level. Mac and Windows, it's not, unfortunately, it's not really built in yet, and it may be a while before it is. Okay, let's go back to the slides now with the availability section. Can you be prevented from receiving an answer? This is, again, our DDoS and reliability section. So all kinds of denial of service are in scope here. The traditional DDoS, which is people sending you lots and lots of traffic until the links of your network run out of capacity and you can't get to stuff. But a DDoS can also target the CPU resources of a server. So it could send a whole lot of queries to a server that you're dependent on for something that's incredibly CPU intensive to figure out. There are some great tools to keep DNSSEC from becoming a vector for that kind of attack. So a validating resolver, if you keep making it figure out validations on new things, that's a lot more work than just telling you, yes, that's fine, we already validated it. But there are a lot of kind of rate limiting and caching tricks for that. But then there are other kinds of denial of service. So a lot of attacks against software and against protocols, you exploit weaknesses in those software and protocols to shut something down or to crash it. So you sometimes hear about packet of death attacks, right? Where there's some piece of software and some input buffer is not being checked for validity before it gets used. And so you can craft a specific packet that you send to that device and it reads it in and bam, the device crashes. So that's an example of a kind of DDoS that can be accomplished with a very, very small amount of traffic and without building a botnet. And last, there are human factor things. So to give an example, during contract negotiations with telecommunications service workers unions, sometimes things have gone really awry and you'll find fiber optic cables inside manholes cut in such a way that both the service and protect loops of fiber service are out of service at the same time. And so then people have to go and do a lot of splicing. That's a purely human factors attack that is denying availability of something. So the exploits against protocols and software, as an end user, there isn't much you can do about that other than just staying on top of updates. Whenever anything new is released to patch a security problem, just make sure that you download it and deploy it as quickly as you gain trust in it. And with human factors stuff, it's process security and training and keeping people happy, and partitioning responsibility is really how you take care of that. And that's no different in the DNS than in anything else. Now, let's talk about how we keep the system as a whole resilient and reliable in the face of these kinds of attacks. Diversity is huge. Having a lot of different kinds of software and having redundancy between things that are running different kinds of software. So for instance, having some servers running bind and some servers running NSD and some servers running Power DNS means that if there's a vulnerability found in one of those packages and it's exploited, still 2/3 of your infrastructure is working fine. And if you have enough infrastructure, you can shut down and take offline and patch everything that's affected without any users being taken out of service. So that's where you want to be. As an industry as a whole, we want to have a lot of different service providers using a lot of different software packages on a lot of different networks so that we have resiliency just due to having a lot of diversity in the ecosystem. Now, the other thing that helps a huge amount is caching. Because we have this hierarchy with tiers and caching in each tier, when something goes wrong, it doesn't affect everybody instantly because a lot of people still have the cached answer. So for instance, the .iq top-level domain looked like it was going to go completely offline about 2 months ago because I'll just go ahead and say what happened because it's worth learning from. So the guy who is primarily responsible for operating and securing the .iq master name servers got a scholarship to go do some continuing education out of the country. And so he left for a few weeks to go do that. And at some point during that time, the people he reported to realized, well, you know, there were these systems that he was maintaining and he wasn't there keeping an eye on them all the time. And so the safest thing to do would be just to unplug those from the internet until he got back, because they didn't really know how they worked. They didn't know how to deal with it if something went wrong. They knew it was important, and that, you know, if it went wrong, the whole country could be embarrassed, right? So they unplugged the hidden master servers from the internet. Now, if those were the servers people were actually querying, the whole country would have gone offline immediately when they unplugged them. But in fact, there were a whole bunch of layers of caching, because there was caching in the distribution infrastructure between those hidden masters and the signers and the distribution servers and the public-facing Anycast servers and the recursive resolvers and the caching resolvers and the local system resolvers, right? So there were effectively several weeks between when this happened and when people would have been affected. And so even though about 20 days got used up in trying to figure out why things weren't answering, people sitting around wondering whether the problem was going to fix itself, eventually, you know, figuring out that the guy was off, you know, studying at a university somewhere, and, you know, him figuring out what had happened remotely. 20 days got used up, and we were less than a day away from them actually going offline. But if you think about it, 20 days is a huge amount of buffer to fix a problem. Now, at the same time, all of those cached answers are ones that aren't hitting that master server. So imagine what would happen if none of that caching existed, and every user's query, every single query went directly to the authoritative servers. Those authoritative servers would have to be gigantic. It would be extraordinarily expensive to operate a DNS service if that were the case. That's just not practical. So what we really depend upon is having a deep infrastructure with many levels of caching, and also having it be sort of broad in the sense of lots of diversity and different options and competing service providers in each niche, and, you know, different code that people can choose to run for different functions. So that's what makes everything really healthy. Now, on the right hand, and that's what's depicted in the left there. On the right-hand side is what happens when people don't run caching resolvers. They don't have system resolvers. They're depending upon a small number of public recursive resolvers, and those small number of public recursive resolvers are talking to a relatively constrained number of authoritative servers. That is, the authoritative DNS market is consolidating over time. There are fewer people running their own authoritatives. More of them are outsourcing. And they're getting to be a fairly small number of big public recursive resolvers. And that's because there are these, what were originally called Smurf attacks, these attacks that depend upon being able to multiply traffic, where you send one small packet to something and you get back a huge response or a whole bunch of responses. Those kinds of traffic multiplication attacks, public services are particularly vulnerable to those. So running a recursive resolver means that you have to do a lot of work to prevent it being used in those kinds of attacks. The bigger you are, the worse the potential effect on a victim is. So the more work you have to put into being responsible about preventing them. And that's just this sort of self-reinforcing cycle that says you got to be bigger and bigger to be able to afford to run a recursive resolver. And so fewer and fewer people do it. And there becomes this sense that it's something that people shouldn't do because it would be irresponsible to, because they couldn't put in the necessary work to keep from being used in these attacks, amplification attacks. So we're in this cycle that is tending towards monoculture rather than tending towards diversity. And we'll talk a little bit more about that later on, and how that problem is playing out. Again, let's go back to the poll and see where people are on some of these issues. The first question: are any of you using any of these techniques to make your domains more resilient? So in-house authoritative name servers. So if you're responsible for publishing a DNS zone, if you have a domain of your own or a TLD of your own that you're responsible for, are you running your own authoritative name servers? Are you using authoritative servers that are being provided by an outsourced provider? Are you doing Anycast? And are you using hidden master servers? Master servers that are available to the Anycast distribution servers, but are protected from being accessed by the internet as a whole. So it looks like a fair number of people are responsible for authoritative DNS and are running their own name servers. About half or a third are doing Anycast, and a little bit less than that are using outsourced authoritative name servers, so service provider. And as Amrish is undoubtedly going to tell you a little bit about, AFRINIC can act as an outsourced authoritative name service provider under some circumstances, I believe for African CCTLDs. Only a few are running hidden master servers. So the point again of a hidden master server is to have a master that the outsourced authoritative can pull zone data from, but which is not itself going to get attacked. That's if you're using an outsourced authoritative name server or service provider, you really want to look at setting up hidden masters that will greatly reduce your attack surface. Okay, let's move on to the next question. How do you schedule software updates and patches? So do you update software only when a server needs to be rebuilt anyway? Or do you update software when you receive a notification from a vendor? Or are you going out and trying to make sure that you get notification from certs and other sources of vulnerabilities, even if the vendors are not telling you? One of the reasons to go fairly proactively out to certs and not depend on vendors to tell you, vendors go out of business, vendors will try and hide things, vendors may not themselves be aware of something. Often vendors will use an operating system or a component that is coming from somewhere else, and so that will have a vulnerability and they won't know about it. And they think of themselves as sort of selling a product that is made up of a bunch of modules, but the modules are actually not things they're responsible for. So sometimes you need to know what the products you're using are made up of in order to know when a vulnerability is applicable. Okay. All right, let's go on to confidentiality. This is probably the most interesting and politically sensitive and topical thing we'll be talking about today. Since Snowden, people have paid a lot more attention to the question of how many people are paying attention to what they say, how many people are recording it and decrypting it and keeping it archived and keeping dossiers on people. So information security, keeping control of your own information, is a good practice because it gives you flexibility, it gives you the ability to sort of self-govern. There are people who say, well, if I don't do anything wrong, then I don't need to worry about this. And it doesn't matter who knows what I do. But that's a really outmoded way of thinking about confidentiality. If you have a 4-year-old child, they're not doing anything wrong, but you still don't want video of them to be out all over the internet getting used for purposes that are outside of your control and coming back to haunt them later, right? And that's just obviously one example. If you're a company, you don't need to be engaged in something criminal to not want your books splashed all over the public web, right? So keeping things confidential is just a matter of good hygiene and reasonable caution. So then the question is, how do you go about it? The problem here is that the internet has kind of gone through three eras. The first era I refer to as the communist era of the internet, when the US military decided who would get internet access and how much, and you couldn't buy it, and you couldn't like go and make it and sell it to people. It was, you know, all controlled by one party, and they decided who got it and how much. That lasted from 1968 up until 1992. Al Gore's contribution to the internet was the structure for privatizing it. And it was called the National Information Infrastructure Plan. And that moved from that communist era to a capitalist era in which private companies could go and make internet bandwidth and sell it to people. You could sort of buy and sell and trade and do what you wanted. But most importantly, that era was characterized by customers being people who paid for a service and service providers providing that to customers for a price. Then 9/11 came along and the US government said, and that also coincided with a collapse of the telecommunications investment bubble. So there was a lot of money fleeing the internet industry at that point, and suddenly the US government comes along and says, hey, you know, all you people who are providing services online, you're probably collecting information, collateral with that, or you could be, and we'll open our wallets and pay for all that information about people. And so there are all these companies that were facing bankruptcy because of the investment bubble collapse, who all said, well, you know, this is another lease on life. We can just collect data about people and sell it to the US government. And if the US government will buy it, other governments will buy it. And if governments will buy it, other people will buy it. And suddenly there became, you know, this industry of information brokers who were buying personal information about internet users. And at that point, it's less effective as a business strategy to sell services to more customers than it is to give service away for free in order to maximize the number of customers you have, because those customers are people who you're collecting data about and selling it. So you maximize your revenue by maximizing the number of customers you're collecting data about, and you maximize the number of customers by minimizing the price. Minimum price is 0. Thus, we've got things like Google, where the things, the services that people think of them providing are all free to the public, but the cost of that is that the data is all being monetized and sold. And, you know, what constitutes selling, of course, you know, they'll say, oh, we don't sell the data to third parties. No, they sell services based on the data, and it's reverse engineerable and so forth. This isn't so much about Google as it is about the industry as a whole, having switched from a model where customers could rely upon the discretion of their service providers because the service providers were being paid by the customer. And if they did something wrong, the customer could leave, to there aren't very many service providers. They're all free. There's no alternative that doesn't involve data collection, or very few. Customers don't feel like they have alternatives. And, you know, we're in this sort of monoculture of services are free, but data is being collected and sold. Now, nobody likes to think of their data as being sold, so these companies will all talk about privacy and security and try and make it seem like they are sensitive to users' needs. But, you know, if you follow the money, that's clearly not what's actually happening. So we've gotten into this kind of arms race in the DNS between privacy advocates who are trying to create tools that users and companies and governments can use to secure themselves and keep their DNS activity private, versus companies that depend upon collecting that data and selling it for their livelihood. And those companies are, you know, now a bunch of them are trillion-dollar companies. These are huge, huge companies that occupy a vast portion of the global economy and an even vaster portion of the internet economy. So we're in this tug of war between, unfortunately, relatively powerless security advocates versus giant, giant companies that spend a huge amount of money to consolidate their position. So what's that look like? There's a guy named Bert Hubert, who is the publisher of one of the primary DNS security or DNS service packages. And he got kind of tired of this arms race and started publishing data about it. And so he did a talk at the IETF in 2018 about how the complexity of the DNS protocol was getting worse and worse because people kept sort of piling on additional protocols and additional features as ways of extracting more user data out of the protocol. So he called this the DNS camel, like how many more things can we add to the DNS before it breaks the back of the protocol. So at the time that he published it, there were a couple hundred DNS standards, I believe, amounting to about, this is about 3,200 pages of documentation. So to write sort of a full-featured DNS software package, you'd have to implement 3,200 pages of standards. That's a lot of work. But we're 2 years on from that now. There's where we are today. 5,100 pages of documentation. So of that, about 2,000 pages produced in the last 2 years. This is craziness. It's not a situation that is making things better. Like the number of DNS protocol changes that are improvements is very, very small compared to the number that allow various kinds of monetization and user tracking and so forth. So when we talk about encryption, we talked about earlier about encrypting links between different parts of the DNS infrastructure. The first time this was done was DNS Crypt. This was a protocol that didn't get run through the IETF, so it was never made an internet standard. It was implemented by OpenDNS in 2011, and then later by Quad9 in 2018. Nobody else really implements it on any large scale. It's there, it works, there are people who like it. It's not difficult to implement, but because it's not an open standard published as an internet standard, there are not a lot of tools that implement it. So it's not the direction things are going. Also, rolling your own is never a great idea with encryption because it means not enough cryptographers have looked at it and validated that your methods are sound, and that tends to lead to weaknesses. DNS over TLS is using transport layer security, TLS, which is the regular IETF standard for DNS, in the same way that HTTPS is web traffic over TLS, and FTPS or SFTP is file transfer protocol over TLS. So this is a really good standard way of encrypting a previously unencrypted protocol. It uses libraries and tools that are well established, that have been examined by lots and lots of cryptographers, that are completely open. Yeah, occasionally there are problems found, but they get fixed really quickly because so many people are dependent upon it and so many people are looking at the TLS suite. So TLS is a good way to encrypt something. It doesn't have a lot of downsides. It's been used for a long time. It's been improved for a long time. So that Quad9 implemented in 2016 as the first recursive resolver to do DNS over TLS. Obviously not the first to do encryption. That was OpenDNS in 2011. But other recursive resolver operators really held off on deploying DNS over TLS. Instead, they put a huge push into an alternative, which was DNS over HTTPS. So, as I said, HTTPS is web traffic on top of TLS. So this is putting DNS traffic inside of web traffic, inside of TLS traffic. Now, what would the advantage of doing that be over putting the DNS traffic right inside the TLS? The advantage is that there are lots and lots of tools for de-anonymizing web users and tracking their behavior and their usage patterns and so forth. So if what you're really interested in is monetizing traffic, monetizing user data, you don't like DNS over TLS because it's encrypting traffic but doesn't give you any additional information about the user. But you really like HTTPS because HTTPS stacks can be fingerprinted easily. DNS over HTTPS allows the person on the other end of the connection to tie different instances of a user's use together into a single, what's usually called an information vector, right? A single, the user goes from home to a cafe, to work, to school. And in each of those locations, they do DNS queries. In a regular DNS environment or a DNS over TLS environment, you'd have no way of knowing that those queries were coming from the same user. In a DNS over HTTPS environment, on the other hand, you can identify that that was the same user by fingerprinting them as they move. So that actually gives them a lot more information to sell than they had before. So what you see is the commercial recursive resolver operators drafting this DNS over HTTPS or DOE standard and pushing it really heavily in 2018 and only implementing DNS over TLS as a checkbox item, you know, once they'd already made a significant push to get DOE out there. Okay, so we have the DNS over TLS. If we're just trying to make things better, we have DNS over TLS that can run between the system resolver and a caching resolver, between a caching resolver and a recursive resolver, but the standard is not yet extended, or the work isn't quite finished yet, to get it between the recursive resolver and the authoritative resolvers. But that work is getting done and will be available fairly soon. That will prevent eavesdroppers from seeing traffic between the recursive resolvers and the authoritatives and knowing who it is. Remember though that QNAME minimization, only sending the part of the query that you really need to send, is already helping with that though, and will help in the event of brute force attacks against encryption as well. So defense in depth would indicate that you want to do both. Now, the idea behind DOE, DNS over HTTPS, what they're really trying for is to get the application to send the query directly to the recursive resolver. Remember that this is being pushed for principally by recursive resolver operators, commercial ones. So what they want is for the web browser to send a query directly to them rather than sending it to the system resolver, which might cache, or to a caching resolver, or to a different recursive resolver. So they're trying to trap applications and get the applications captured and sending queries directly to them, regardless of what the user might be configuring their machine to do. Because remember, the system resolver is under the user's control, and the caching resolver is under the user's control. And ordinarily, a recursive resolver would be a choice that the user would be making. So when people talk about DOE having something to do with security, yes, it has something to do with security. It has to do with circumventing security, circumventing the user's control over the system resolver, the user's control over the caching resolver, and the user's choice of recursive resolver. So DOE is really about bypassing all of that security, bypassing the policies of your IT department, bypassing local law, you know, bypassing everything and getting data straight out of an application and pipelining it into the recursive resolver. So obviously there are people who are really unhappy with that. And mostly those people have said, well, DOT is the answer, right? DNS over TLS gives you everything legitimate that DOE is supposed to without introducing new problems. But there are also people who have done something different called adaptive DNS resolver discovery. The idea behind adaptive discovery is if the recursive resolver is the problem, we're going to just bypass the entire thing and go straight from the application to the second level name server, bypassing not only all the user's configuration, which was good, but also the recursive resolver if the recursive resolver is bad. So Apple proposed this and has said that they're making it available to developers basically now. The idea here is that if you're Apple and you know that a user on an Apple iPhone or an Apple MacBook is trying to get to an Apple-controlled website, that the application, the web browser or iTunes or whatever, would just go straight to Apple's web server, or sorry, Apple's name server, using sort of hard-coded addressing, and it would know how to authenticate that server, and it would get rid of all of the attack surface in between and all the man-in-the-middle possibilities and so forth. So you can see why that looks really attractive to them. It allows them to really nail this down, get rid of a vast number of problems and uncertainties. But if we go back to this model and look, what we see is that the sort of DOT augmented topology on the left is our ideal case. The direction things have been going with DOH, where applications are getting pipelined straight into recursive resolvers, that centralizes control and the ability to sniff data quite a lot. But then this problem, this idea of bypassing all of that and going straight to the authoritative servers, the problem here is that it's incredibly fragile, right? Anything goes wrong, all of that traffic is now, orphaned, abandoned, whatever, right? There's no backup plan to this. It depends completely upon the authoritative server being super robust. And if you're Apple, if you're $1 trillion company and you can spend hundreds of millions or billions of dollars on setting up servers, yeah, you can make it pretty robust. If you're just regular folks with a regular company or a school district or a city, city website or something, you just don't have that option. And so what happens? Are you going to have to outsource to somebody that you then have to trust? Is there really no way to operate stuff yourself in the future? Of course not. That's, all possible. It's just not the direction that industry is pushing. So the thing we got to remember is that industry is trying to make money, not to benefit users and their security by and large. Apple is not doing this for the wrong reasons, but they're just not looking at it the same way that individuals would. They're looking at it the way a $1 trillion company would.
Bill, there is a question that's been raised in the Q&A regarding Mozilla and why they are pushing DOH so hard. And this comes from Calvin Brown.
Yeah.
Why Mozilla is pushing so hard.
Yeah, so this is actually, this is a really interesting intersection of a lot of politics. And I'm just gonna go ahead and talk about stuff that is not hugely public, and now it will be. Eric Rescorla is the guy at Mozilla who is responsible for that. And he's somebody who's been really central to a lot of the security efforts in the IETF for a long time. I've known him for now almost 30 years, and this industry, unfortunately, is fairly closed and fairly stagnant. And so it's a lot of the same people doing the hard work now as were a long time ago. So he's at Mozilla, and this is something that he's pushing for. And from his point of view, there are bad actors out there in the path, right? He's looking at this in very much the same way that Apple is, except instead of having control of the domain name on the one side and the application on the other, he just has control of the application, and not the recursive resolvers either. So what his thought was that there are internet service providers that are operating recursive resolvers, sometimes without the knowledge and approval of their users, and are taking the traffic and monetizing it. Now, in Europe, of course, that would be illegal, right? The GDPR protects European citizens from that kind of behavior and gives them a whole lot of rights and really significant financial penalties to an ISP that do that. Now, you know, GDPR enforcement is still not really a thing yet. A lot of ISPs outsourced that, right? They said, well, you know, we don't want to have to run name servers anymore. We'll just let this company do it. And the company says they'll pay us to let them do that, right? So we're not going to pay any attention to this. We're going to cash the checks. We're not going to think about how it applies to users. In Europe, that's no longer a viable approach if you want to stay out of jail or stay out of the poorhouse. In the rest of the world, though, that's still going on. Very few other countries have privacy laws that are as strong as the GDPR. So if it's not perfect in Europe and everywhere else is pretty much worse, we got a real problem there. And so Eric's thought was that he had his fingers in something that would allow him to make that better. The problem is that he didn't have a recursive resolver to send the traffic to if he was going to like take the traffic and bypass the system resolver and caching resolver and so forth. And he also, you know, in controlling the application rather than controlling the system resolver, you know, he only kind of has the thermonuclear option of just sending the traffic to where he wants it to go, not to where the system is configured for it to go. So if, for instance, a machine is sitting in an office and the office has IT staff who are responsible for the security of the employees in that office, and they have a security policy and it involves, you know, DNS traffic not going somewhere else, they've already solved this problem. It's part of their job to do this, but the Mozilla browser is now going to try and bypass that. Mozilla has since come to an understanding that that's bad, and so they put in hooks that allow IT staff to override this feature. But then there's the problem of recursive resolver operators who are trying to garner as much information as possible, you know, wanting to get at more users' data. So, and Mozilla is a nonprofit and is always looking for, you know, ways to do things as inexpensively as possible or make money on whatever. So commercial recursive resolver operators sort of jumped at the opportunity to partner with Mozilla and get access to that data, which meant that something that was good in principle under some circumstances, particularly if implemented with enough sensitivity to still accommodate local needs, particularly in enterprise, became maybe more of a problem than a solution. And, you know, Mozilla is trying to figure out how to deal with that, and they're doing a lot of work. And, you know, from Quad 9's side, we see this, right? Because we're working with them to try and make Quad 9 one of the options that people have, and to make these actually options and not just have people dumped into something that's opt out rather than opt in. So all of that kind of blew up and was in the press a lot. Mozilla got a whole lot of really bad press, which is unfortunate because, you know, they were trying to do the right thing. And I mean, in an ideal world, that conversation would have been more open and the problems would have been raised earlier, and there would have been more conversation about what to do about it, and they would have had more input. And, you know, that's an ideal world. Things aren't ideal, right? So seeing that blow up, Google, who had their own plans to do this as well in the Chrome browser, said, well, we don't really want to get burned quite as badly as Mozilla is getting burned in the press. So we're actually going to back off. And because, you know, in a huge number of devices which run a Google-produced OS, Android, and also run the Chrome browser, we actually do know how the system resolver is configured, right? We can figure that out. So what they said was instead, if your system resolver is configured to support DOH, or sorry, if your system resolver is configured to send queries to a recursive resolver that supports DOH, then we'll just use whichever one you're already configured to use. Great, right? It's a way of providing the encryption without overriding user policy. So that's a good thing. You know, I have no doubt that Google would not have taken such a conservative and nuanced position had they been the first one out the door. They would have instead been the ones to get burned by the criticism in the press. So where things stand right now is that this stuff is not widely deployed yet. I think it is rolled out for Mozilla for the US only. Mozilla is sending that traffic to Cloudflare. Mozilla is talking with others, but you know, that's sort of hung up in lawyers and, you know, agreement negotiation and so forth. Google just went ahead and did something where they don't need any explicit agreement with anybody. So, you know, that just works. And I don't know what stage we're at with them rolling that out. James or Michelle might know specifically. And we can certainly get an answer for that if any of you want to pose that as a question. But the problem is this is all DOH, right? It's not DOT. And the problem is that it's bypassing local security mechanisms, right? In the slide earlier, I showed the problem with all of this is it's trying to solve a problem in the place where the problem doesn't exist mostly, right? Mostly people don't have a problem with the security of their system resolver or their caching resolver if those exist. So like saying we bypass those is not an advantage, it's a disadvantage. The right answer is just to get DNS over TLS operating sort of throughout that chain and to move DNSSEC as close to the system resolver as possible. You don't want individual applications having to do DNSSEC validation. You want the system to provide that as a service for them. But you really do want that in the device. There are a lot of attacks against the traffic between devices and recursive resolvers, or against recursive resolvers or malicious recursive resolvers, such that doing the DNSSEC in the device is the right place. And depending on the recursive resolver, no matter how much you trust them or want to trust them, it's just not the right place to do it. Okay, so let's talk a little bit. So I think I've got quite a bit of answer out there on that. And we'll try and summarize it in text, you know, as we get the written answers out there. So let's talk a little bit about other things that you can be doing as well. So getting a cache in place at the edge of your own network is really the simplest, easiest, cheapest thing to do to improve the situation. Ideally, you want that cache to be serving a bunch of users, partly because that's amortizing the labor over more benefit, but also because then the population below the cache is larger and the cache hit rate is going to go up and the amount of privacy protected goes up as the cache hit rate goes up, right? Fewer queries from users result in a query leaving the organization. So getting a caching resolver in and configuring the caching resolver to do DOT, that's your biggest win for the least effort. There's something called NSEC aggressive negative caching that can be done in a caching resolver, which basically says that you use DNSSEC to understand when, okay, let's say that we have a name here and a name here in a zone, and the zone has been sorted, right? And signatures have been done on each thing, but also signatures are done between things, saying there is nothing between these two answers, right? So if we sort things into an alphabetical list, for instance, and you know, we've got the name Abraham and the name Emily, and those are adjacent to each other in the sorted list. We can also sign the gap between them and say nothing exists in between these. Now, a caching name server can get that record. And so when it gets a query for something that doesn't exist that's in between those, it can respond and say, we know that nothing is there, without ever going back to the authoritative server and without ever exposing that query to the rest of the world. That's actually a surprisingly effective thing to do, given how many bogus queries there are, how many queries there are for things that don't exist. It also can be used to break cache busting attacks, another form of attack. Okay, keeping a local copy of the root zone. The root name servers, there's been a huge amount of sort of international political intrigue around, you know, who controls the root name servers. But really, since the advent of DNSSEC signing of the root name servers, or the root zone in about 2007, 2008, what's important is the content and the signature. Where you get it from really doesn't matter. If it's current content with current signature on it, you could have gotten it from anywhere. So you can just get the content and serve it yourself to your own users. Why not? That's a thing that's happening more and more. So people who are running a local caching resolver are downloading a copy of the root zone, which is tiny, and throwing it into their cache, and it's DNSSEC signed, and so then they never have to do another query to the root. And that, in combination with QNAME minimization, in combination with aggressive negative caching, in combination with having a big cache, really minimizes the amount of outbound data that you're leaking. So again, defense in depth means layering these techniques on top of each other in order to get the most protection. All right, let's go on to the poll again. And this one is, are you encrypting DNS queries to recursive resolvers? And the second question is, are you using other methods to make your DNS communications private? So first question, are you encrypting from caching resolvers using DNS over TLS, or from applications using DNS over HTTPS? So that's like Mozilla, for instance. From caching resolvers to DNS over TLS, using DNS over TLS, that would mean like you're running a recursive cache, or you've somehow otherwise implemented DNS over TLS, and you're sending your queries to a recursive resolver that way. And then no is not encrypting, and other is, there are a lot of different possibilities there, and so other is kind of the catch-all. Okay, so most people, again, are not running caching resolvers, which explains why they're not doing DNS over TLS from caching resolvers. Looks like one respondent's using the Mozilla with the DNS over HTTPS, or otherwise doing it from an application. Most people are not encrypting their queries to caching resolvers. So encryption done right is the single biggest thing you can do to give yourself some privacy, assuming, again, that you kind of trust your recursive resolver. All right, let's go on to the next question. Are you using other methods to make your DNS communications private? Local caching, QNAME minimization, NSEC aggressive negative caching, local copy of the root zone. So is anybody doing any of those techniques already? All of these things, of course, depend upon being supported in software. As end users, you're not going to go out and write new DNS software and implement 5,100 pages of documentation in code. So it really depends upon having access to software that support these features. And this ecosystem of software is unfortunately not that huge. So, all right. The local caching seems to be, I mean, that's, as I said, the single biggest win. So I'm really glad to see people are doing local caching. All right, let me turn it back over to Jim, who will introduce Amrish and his slides. Thank you very much.
Bill, thank you. And we now have Amrish from AFRINIC, who's going to provide us with a snapshot of the perspective in Africa as it relates to these issues. So Amrish, floor is yours. Thank you.
Thank you, Jim. Hi, everyone. Thank you for being here tonight. Thank you, Bill, for giving us a very good overview of the techno-political game happening at the ITF. I think many of us don't know that it's actually a lot of lobbying happening, and mixed with technology, it's quite interesting, actually. So today, my talk is about giving you an overview of the state of DNS in Africa. You might actually be asking yourself, why is AFRINIC interested in the DNS? Because we are mostly into allocating internet number resources, IP addresses, basically. But we have something that we manage called the reverse zone. So similarly, as you have the TLDs, for example, the .NET or the CCTLD, like the .ZE, .KE, etc., you have a special zone called the ARPA zone, which is used for the reverse zones. And reverse zones are usually used, for example, to create PTR pointer records. And normally what you do with the reverse zone is you map an IP address to a host name instead of a host name to an IP address. And this is used by internal mechanisms, for example, nameservers, to verify that the source is indeed the one that is sending the message and things like that. So we manage the block IP block that we allocate from, and whenever we allocate IP addresses to our members, which are the internet service providers, we delegate the responsibility of managing the zones. At the end of the day, because the DNS is a hierarchy, they need to send us the information of the name servers for the individual zones they are managing. And we are doing the same with the parent, which is ARPA, and then the root. So in the past and also currently, we are doing a few studies. Of course, we are interested in the health of the DNS infrastructure, namely the reverse infrastructure, but we're also interested in understanding what's happening, for example, in the CCTLD space in Africa. So there are, I would say, maybe four main questions that we are asking ourselves. So the first one being, how accurate is the information in the DNS? As you know, accurate and up-to-date information in the DNS is important. And there are cases, of course, if the DNS information is not properly maintained, when your recursive resolver will ask the question to the authoritative name server, they won't get a good answer, or they will get a bad answer. And this can negatively impact, for example, DNS resolution time and consequently quality of experience of the end user. The second question is the zone redundant? There is at the ITF a best current practice called BCP 16, which gives a few hints on how to make a zone redundant. First, it says that you need to have at least 2 authoritative name servers that is serving that zone. And it needs to be in geographically and topologically diverse networks, which means that it's not good, it's not actually recommended to have your 2 name servers in the same network and in the same place. Better you have it in 2 different places or 2 different regions or continents. And of course, in 2 different networks. For example, if one network goes down, you can still access your other authoritative name server in the other network. And as Bill has lengthily talked about, our domain operators, so for example here, CCTLD operators signing their zone, or they're providing a DNSSEC to protect the authentication of origin and data integrity of the data which is in the zone. And we will also see that data that we have gathered from AFRINIC, what is the percentage of validation? So of course you have the signing part, but you also have the validation part, which is done by validating recursive resolvers. We will have a look at what's the percentage of validation in Africa. So starting with DNS accuracy, I have counted, we have in our region 57 CCTLDs. We have 54 countries, but we have a few more regions that have their own CCTLDs. And out of them, we have 225 unique name servers serving these 57 CCTLDs. And there is something called name delegation. Basically, sometimes people would come and put wrong information or outdated information. And we consider these information lame. For a lame name server, for example, is an authoritative name server which is not reachable, or sometimes they cannot be reachable over UDP or TCP, which is very important for DNS and DNSSEC. So if we have a look at the percentage, what I've done here is by CCTLD, I took the number of name servers, authoritative name servers, and I had a look at whether they are, first of all, working. Each CCTLD have a working name server. And secondly, whether they are reachable over UDP and TCP. And the good news is that most of African CCTLDs are working properly, with the exception of few cases here like Cameroon and Niger, which is around, I would say, the 60% of the name servers which are not working properly. And we have Egypt, which is yellowish here, around 40% of the name servers which are not reachable. So these are lame servers that needs to be corrected to make the DNS infrastructure in that country more resilient. So now we are looking at resilience itself. Zone redundancy. I mentioned that the best current practice actually recommends that for a zone, you need to have at least 2 name servers. So let's have a look at what is the distribution of name servers. We have seen that only 3 CCTLDs have only 2 name servers, but the rest have at least 3, 4, or even more than 4 name servers, which is quite good. And who are the countries? And on the other side, we were also looking at the distribution of unique AS numbers. So basically, in which network, how many different networks are your CCLDs hosted? And more or less, it's fine because you have a lot of yellow here, yellow being at least 3 unique AS numbers, which means 3 different networks. But you see some countries which tend to be orange and green and red, especially here Ethiopia. Ethiopia actually has only 2 name servers, and both in the same country and in the same network, so which is not that ideal. And in terms of geographical diversity, here, so we take all the CCTLDs and then get the number of name servers, and then I try to see where are they located. For example, are they located in the AFRINIC region, the APNIC region, ARIN, LACNIC, or the RIPE NCC? So AFRINIC being Africa, RIPE NCC being Europe, for example. And when you see red, it means that these countries have their all of their name servers located in only one region. So it means that geographical diversity for these CCTLDs is not ideal. So we have a few countries like this. For example, Ethiopia, as I mentioned. This is Guinea. This is Mali, and so on and so forth. Now, DNS Anycast. You might have heard that it is also important to use DNS Anycast services. AFRINIC is a provider of DNS Anycast. For example, we provide secondary authoritative for all the CCTLDs in Africa. So if you're interested to join this program, feel free to contact AFRINIC. And then our DNS infrastructure is Anycast actually. PCH is also providing the same service where you can use their Anycast service, and of course it is well distributed in the globe. So what are the benefits of using a DNS Anycast? Of course, it provides better redundancy and protection against DDoS and DNS flood attacks. And of course, by virtue of using an Anycast service, it is also closer to the end users. So this means that you will have better quality of service thanks to reduced latency to those Anycast servers. So are African CCTLDs actually signing their zone? Let's have a look. A few of them have started to sign their zones. Actually, 30% of CCTLDs have activated DNSSEC. Some of them are operational, like Tanzania, Kenya, South Africa, Seychelles. Some of them have tried. For example, Senegal, Mauritania, Guinea, Liberia, Tunisia, they all have what we call DS en route. DS stands for delegation signer, which is basically a glue that you need to put into your parent so that you build a chain of trust from your zone to your parent zone up to the root. So we have seen a tendency of some CCTLDs going towards DNSSEC, but they did not complete the process of now signing their zones. They have just published their DS to the parent, which is a good step, but they need now to actually get into operation and sign their zones. And in terms of who is validating, this is data coming from AFRINIC. So Africa is validating at around 22%, and the world is validating at around 26%. Which means we are not that far away, but still, I guess we have a lot of work to do. Especially as you see here, the orange and green, the orange and yellow, we still have some work to do. Only where you have green, for example, here Sierra Leone and Somalia, they have activated zone validation. But this can actually be explained because in those countries, it's usually only one network or the incumbent operator. And the good thing is that they have activated DNSSEC validation, and that's why we see green here. In other countries, we have many more networks. For example, in South Africa, some networks are validating, some networks are not validating. And as Bill mentioned, the signing algorithm is also very important, an important parameter to take actually into consideration when managing a DNSSEC infrastructure. As you know, some algorithm with time they will get weaker. For example, the RSA SHA-1 is actually very vulnerable to hash collision attacks, and in that regards, for example, the ITF will put out recommendations saying that DNSSEC operators should not be using those algorithms. We have also found that DNSSEC, in DNSSEC specifically, it takes a lot of time for new algorithms to mature and also to get out there, because you need all the software implementers and also the underlying crypto libraries to implement those new algorithms. So it can take time, up to 5-7 years actually, to get implemented in some cases. So which means that the algorithm agility, as we call it for DNSSEC, is not that great. But I suppose people are working towards making it better. So what's the situation in Africa? Well, we have seen Seychelles and Namibia, .NA, which are using a weaker algorithm, for example, SHA-1, and this is not recommended at all. So if there's anyone from Namibia, we would really urge them to contact their CCTLD operator to get that fixed as soon as possible. So what can you do? In terms of resilience, government should encourage CCTLD operators to operate the infrastructure within their own country, so that it is closer to the end users as well. And it also will strengthen the national ecosystem. For example, if there is an IXP, that can be an added service from the IXP, and then this will actually help them attract more peers from the country. I mentioned about data accuracy, that it is really important for data to be accurate at all times in your DNS, so that you minimize query time and also the number of times the query is done actually. I mentioned about the BCP16, which recommends that you have to have at least two operating name servers in geographically and topologically different places. And of course, we would encourage CCTLD operators to get on board with DNS and NICOS programs that PCH and AFRINIC is offering for better security, resilience, and performance as well. And in terms of security, of course, we would recommend everyone managing a zone to do DNSSEC, and not only to do not only to send their DS record to the parent, but also to start accepting DS records from their child zone, and also signing those zones. Algorithms using the latest and not necessarily the latest, but at least the recommended algorithms for signing is important. Also validating, because it's good to sign, but it's also important to validate to protect your relying parties. And of course, some companies, and for example, Quad9 provide anti-malware services, which we would encourage normally network to implement. And finally, policy plays a big role. If you can get involved at different level, whether it is local in terms of coming up with regulations that can protect the DNS infrastructure, or for example, create a good working ecosystem to have your CCTLD locally. We would urge you also to participate regionally, whether it is at AFRINIC or AFTLD meetings, and also globally at ICANN. Of course, the best would be to have community-based CCTLDs. As we know, it's always good to have a community around a CCTLD to make it more vibrant and more also I would say democratic in the operations of the CCTLD. Yeah, I think that's it for me. Thank you.
Okay, so I think the next step was we were going to spend a little bit of time just having each of the folks make their 1 or 2 best recommendations. Why don't we go in the order on the page there? James, are you able to?
Hi. Yeah. Hi, everyone. It's James Mitchell from Packet Clearinghouse. I'm not sure if you can hear, but sorry, my daughter woke up with me early this morning. I'm sort of not been able to follow as long as I'd like. So I'll
James, her insights may be the most useful here. No, I'm just kidding, but thank you for being on with us.
No, yeah, I guess. My take on it is, I mean, I'm predominantly coming from the authoritative side. Is organizations when deploying DNSSEC, as Bill mentioned, the .iq story. I think the technology side is easy, but the ongoing personnel training and I guess the risk management from that side is probably something that's often overlooked. And so any support, any push to sign your zones, you should also consider, training your staff and then being willing to continually train new staff as they come on board.
Yeah, I think what James is saying, we've certainly seen over time. We've been providing DNSSEC key management services for CCTLDs for 15 years now. And CCTLDs, some are incredibly stable and some have a lot of turnover. And when they have a lot of turnover, it's very difficult to maintain the sort of human expertise needed to deal with exceptional situations. So that's an instance where a CCTLD, if they can't sort of develop and maintain the internal expertise, might want to look at outsourced.
Yeah. So that's pretty much it. The other thing of note is the DNSSEC does introduce time into the DNS. Signatures have an expiration time, and once they expire, that's it. So it doesn't matter if your zone's serving, or it does matter if your zone's serving stale data. And so that's keeping that knowledge up to date and having that urgency around resolving these issues, or monitoring one and resolving potential issues is sort of paramount. That's it for me.
Nishal, do you have any sort of wrap-up tips and suggestions?
Hello, everybody. My name is Nishal Govardhan. I work at PCH along with Bill and James. I'd like to remind the people attached to this call that literally all the technologies and all the techniques that have been discussed on the call, while some of them might sound really difficult to get off the ground, there's always people that are willing and able to help you. I was going to mention, and Bill just literally said it, that if you run a TLD, if you're responsible for a country code top-level domain, there are folks that can help you get this signed. And while it might sound that we're just saying, guys, go ahead and tick this box that says DNSSEC for your CCTLD, it's important you understand that there's a whole economy that's attached to this that's important for the rest of your country, and it's going to go outside the scope of this talk, but really there's a list of things that matter, things like defining yourself, defining your own economy inside your country, being able to use technologies like DANE, being less reliant on external components of the internet to make sure that you can run your component of the internet safer. And all of that is really, really integrated. I think this might come across in future workshops, but it's not just a tick box. That's the point I want to make. There's a set of dependencies that's important that you get it done. Technologies like DNSSEC, technologies like Anycast are what's going to make it safer, easier, and faster to roll out future African, this is an AFRINIC webinar, so African solutions. And the thing is, while it might sound difficult, again, it's not. There are lots of people that are willing to help you. My email address is in the slides. My email address is in the chat as well. And it's literally my job to do this. So please feel free to write to us for assistance. And if we can't help you, we'll point you to people that can.
Okay. Amrish, I know you just had a whole slide of recommendations, but is there any one that you would pull out as sort of the highest priority thing to give people as a takeaway?
I would say getting involved in policy is important. I have a good example. At AFRINIC, we had a huge problem with the lame delegation. And so basically, I think around 50% of all the information in our DNS, so all the name servers that our members that are basically the ISPs out in Africa, 50% were lame, were wrong. And then, so some people came up with a policy. Nishal is one of the co-authors, and said, "Okay, AFRINIC, you need to handle this." And I would say a month of the implementation of the policy, there was a drastic decrease of the lame delegation to around 10%. So, which means that policy works. And we would like to encourage actually people to come up with more policies that actually can help make the whole DNS system more robust and more resilient. Yeah.
Okay, and for me, I think the one thing I keep coming back to, particularly in light of the poll results, is that setting up caching resolvers. Setting up caching resolvers is really the thing that you can do that will make a huge difference in your security posture, your performance. It's a bit of work, but it's worth doing. You could even set one up on your laptop and direct your local queries to the caching resolver on your laptop, and then have the laptop send them out encrypted. There are plenty of tutorials out on the web on how to do that, how to set it up. There's something called Pi-hole that a lot of people use that performs ad blocking and some sort of firewall features and so forth. All of this functionality is built into most firewalls. So that would be the one thing I would try and leave you guys with. Now, I think the last thing is we're just moving over to sort of open discussion and Q&A. If there are questions that folks have teed up, I'd love to see them. Jim, do you want to take over the moderation of the Q&A? If there aren't questions already teed up, we can go to some of the ones that we carried over from the last DNS workshop as being more advanced.
Yeah, many of the questions, well, I guess all the questions that have come up have been answered in the Q&A section. So maybe queuing up some of those, but just in terms of, the policy, issues that you raised, around this and looking forward, if possible, as you, think about, the coming months and years and how this evolves in terms of discussions with, in government forums or also in forums like the IETF and with companies who, do exert influence there. Where do you see this going, and what are some things that are important for all of us to be thinking about?
Yeah, I think, a lot of the problems that the world is dealing with right now come from this greater and greater separation between resource haves and resource have-nots, right? Fewer and fewer number of companies handling more and more of the world's transactions, and more and more people essentially unrepresented in the economy. And this centralization of power is a policy decision, right? It's something that people who are trying to centralize power for their own ends always push for. And you can kind of take for granted that they'll always push for centralization of power and resources and so forth in their own hands. And if nobody pushes back, then they succeed. And that's been happening in the internet for 20 years now, 19 years now. We've been having greater and greater centralization, fewer and fewer successful startups. Every part of the internet market becoming more centralized. big companies acquiring their competitors and shutting them down. It's not a direction that's healthy, and it's not a direction that's good for people. The higher the bar gets raised to new market entry, to competition, the worse it's going to be for the economies of every country that is not the host to and in thrall to, you know, those few companies. And the reality of it is that almost all of those companies are in San Francisco and in Seattle, right? You know, sure, there are other companies. There's Deutsche Telekom, there's Huawei, so forth. But and you know, China is trying to do the same thing. China is trying to make their industries as successful as possible globally. But that still doesn't help somebody in Tanzania or somebody in Egypt or somebody in Ethiopia, right? In order for companies in those countries to become really successful, they really need to be on a fair playing field, one in which you don't have to implement 5,200 pages of documentation in order to, you know, set foot in the ring, right? So I think, you know, as several people have mentioned, participating in the policy process is necessary in order to maintain a foothold, in order to maintain a seat at the table. If you don't show up, decisions will get made and they won't favor you. And I think that's of pretty critical importance for, you know, the vast majority of the world's countries that are not particularly participating in internet governance right now. It's never going to benefit a developing country to have its citizens dependent upon services provided from and governed in another country. It removes regulatory authority and autonomy. It makes a mockery of local law. And ultimately, it defeats the ability of kids growing up in that country to look at the world and say, you know, I have an equal chance of success. And so it's not the world we want to have going forward, but it's the world that we've been building for 19 years now. So we need to make some really conscious policy choices around decentralization and openness and autonomy. And so fundamentally, what you want to look at is the difference on the one hand between self-hosted open source, and on the other hand, the cloud, cloud services. Things that you can do for yourself using open software, ideally that you don't have to pay for, where you can inspect the code and see how it works and learn how to do it yourself if you want. Those are the tools you want to be using, because those are the only tools that you can trust to be secure. Anything that's happening off on somebody else's server using proprietary code that they know and that you don't, you can't trust that ultimately. And I say this in full recognition of the fact that PCH is providing lots of services to people, but we only do so using open source code, right? And we'll happily, you know, tell you exactly what code we're using, what version, and so forth. And you know, that's sort of the best that we can do while still being a provider of services. But what we really like is to help people do it themselves, to help people figure out this stuff for themselves, run the software themselves, develop local expertise, and then, you know, go on to doing it as a business for themselves, go on to setting up other things like that. Because that's how the global economy will grow, rather than just the economy around San Francisco and the economy around Seattle. So I think, you know, focus on open source, focus on things that have been publicly security reviewed, focus on self-hosting, not in the cloud, and you know, whenever there's a choice between doing something locally and doing something in somebody else's economy, just do it locally, because that's going to increase the pool of people that you can rely on, right? That you have access to, that have common interests with you. You know, if companies are constantly choosing to use AWS instead of building a server and throwing it into a local data center, A, the local data center isn't going to survive, but B, you're not going to have a crop of kids who know how to build servers and install software, right? And if you don't, then what's your alternative? You're going to go back to AWS. So these are conscious decisions that have to be made and pursued, and they take time, and you know, you don't reap the benefit of them immediately, but if you're not steering in that direction, things are just going to keep getting worse and worse. And the DNS is just sort of one instance of this, but it's an instance where the politics have been playing out very dynamically and vigorously and publicly. So I would say that, you know, the DNS is an example to look at, but recognize that, you know, the whole W3C and web stuff is, you know, exactly the same kind of thing. Right now, we're using Zoom, right? Zoom is a proprietary service running in the cloud using proprietary protocols that are not as good as the open source stuff and open protocols that we had 15 years ago. 15 years ago, we could have done this with Jitsi and Jabber and SIP and RTP. And all those protocols, huge amount of effort of good people went into making these things open so that everybody could use them at no cost equally and interoperably, and, you know, could choose what tools they wanted to use and not have to descend into a monoculture. And we've lost that, you know, to a very great degree. So we need to start aiming for that specifically again.
A question that has come in from one of our attendees anonymously. They ask, as an authorized DNS provider for their customers, what motivation do they have to incur the cost of implementing DNSSEC? And they, for more context, they say they are a web and DNS host, if that, you know, matters and has any bearing on the answer.
And it says there, I can see that Nishal is going to answer this question live. Is Nishal?
That was Nishal flagging it for me. So that.
Oh, I see. Well, why don't we give somebody else? I've done a lot of talking. Nishal, why don't you actually answer that? Or James?
Or Bill, I think that, yeah.
Well, maybe they're.
I'll just throw in 2 cents and just say, ultimately, you know, it is a business decision. And, you know, we're seeing some customers that, you know, are signing their zones and will only pick providers that sign their zones. Or support signing. You're granted you're in a slightly different space where you have, you know, smaller zones, more authoritative records, right? So there's a lot more signatures. Sorry about that, right? And so there's sort of a bit more complexity in the key management process there than, you know, just a handful of zones. But yeah, so that I can't really comment on trends in that space, but yeah, business decision ultimately.
For me,
I wouldn't go so far as to say there's a negligence factor. I don't think anyone could ever claim that. But you know, doing right by your customers. Yeah. Again, it depends on your brand.
Yeah, and I think it depends whether you want to be, you know, you want to have a competitive edge. Me personally, if I want to buy a domain, I would like to know whether the operator of the domain is actually signing my zone, and that would be actually one criteria, for example, to select a TLD.
Well, and so to be really frank, the danger here is that you undertake this and you get, you know, your customer zone signed and they get used to it and people get used to depending upon that. And then you slip up and suddenly they're not signed and they're throwing errors all over the place, and you get a whole lot of complaints. And because it's security, nobody will have been willing to pay extra for it, right? That's the problem.
So I think, oh, sorry, Bill, keep going.
So until it becomes the expectation that everybody will do it, it's really hard for anybody to individually justify the investment and the risk and the commitment. And yeah, that's the tough part of the chicken and egg here. And that's what DNS signing really prevalent. I think it's something we know we need to do. It's something that you can advertise as being more secure. I think the trick to it is really to minimize your risk by looking really carefully at how you set it up and not doing anything unusual or out of the ordinary or more complex than usual, or that will like create short time windows in which things have to happen, which unfortunately coincides with vacation that somebody takes 3 years from now, right? That's what you really want to avoid. You want to avoid something where a deadline is going to come up and something is going to have to happen in a short period of time, else something will get broken, right? And you want to think a lot about the people requirements and what knowledge someone will have to have and how many people have that knowledge and will be available. Yeah, I mean, the way PCH does it, we try and do the most responsible, hardest thing that we think can still be replicated by somebody else, so that if there's going to be a problem, we'll run into it and know about it and understand it before everybody else does. I mean, since James is one who's responsible for it, I hate to characterize it that way, but you know, we're trying to do a replicable best practice. We're not trying to do the absolute simplest thing. And I would never recommend that an ISP just go and copy what we do, because the way we have it set up requires a bunch of people to be available in sometimes inflexible time windows. The things I would suggest that you do are make sure to train and document, automate what you can, and make sure that you are always creating as much leeway for yourself as possible in terms of the run out times of signatures. Generate signatures well in advance, big pools of signatures that you can draw upon. You know, don't have a single appliance box that you're dependent upon that if it crashes, you know, you're going to be in an emergency in 24 hours, right? I guess that's sort of my.
Yeah, the context was a couple of 100,000 zones. I think looking towards Europe, I mean, there's a couple of different models as well. Some providers have looked to charge their customers for it, and you know, I think, you know, to some degree, you could ask an enterprise user to throw in $5 or $10 a month or whatever, and they'll probably swallow it, or at least, you know, here they'll potentially swallow it in the name of security. But you know, it's, you know, Europe, I think they went down the approach where let's just do it for everybody and not charge anyone, and so yeah, you're seeing like a great percentage of uptake in I don't know if it's DE or NL, Netherlands. So there are some places where it's sort of done at scale at that sort of second level and below.
Any of our panelists think of anything that we haven't really covered that we should before we wrap up? We're at this point 10 minutes over the time that we sort of guaranteed we would be available. And so some people may be running short on time, but we also committed to stick around as long as anybody had things that they wanted resolved or wanted, you know, to discuss.
And the other thing that I'll just say, just to remind everyone who is still with us, you know, that as Nishal mentioned, that, you know, the teams from Packet Clearinghouse and AFRINIC are available if there are things you think of after the session for which you would like more information, or if you think of another question that comes up, do not hesitate to reach out and let them know.
Yeah. Okay. Why don't we wrap up then? And you can expect an email from AFRINIC shortly that will survey you about this webinar, what you think could be improved and so forth. And it will also ask you what topics you'd like to see covered in future webinars. And we are using that to figure out what content we need, who to bring in as speakers. I know we're going to be doing one on Anycast specifically, because there have been a lot of questions about how Anycast works and how you set it up, and how to sort of get the most advantage from it, what pitfalls to avoid, that kind of thing. That's a workshop that we've done many times before face-to-face, so it's an easy one for us to transition over to webinar format. Another one that has been discussed is the sort of cryptocurrency and monetary policy, and how you know, the internet and money and governments going forward are going to work together. And that's something that we'll probably bring in a few guest speakers to help address if there's enough demand for us to do that one. But any suggestions that you guys have are very welcome, and we'll probably put forward a bit of a multiple choice of ones that that we're ready to do soon for the upcoming ones.
And again, thank you to Bill and Amrish and everyone who helped make this possible. You know, Bill mentioned the trainings that we traditionally do in person, and while we all wish that we were able to be in person, during this time, it's a way for us to stay connected and continue sharing information and experiences. So really do want to thank everyone, and look forward to welcoming you back for what will be our next session that we host together. So thank you, everyone, and have a good day.